Whilst we're on the subject of circles, I'd like to discuss the equation for finding the circumference of a circle. This is a very simple equation that's very easy to explain, so I imagine this is going to be a fairly short video. Now, whilst it's perhaps not as immediately useful as equations such as Pythagoras' theorem, this is another one of those equations which is useful to have in your problem-solving arsenal. And that's because occasionally a problem will crop up where by being able to work out the circumference of a circle, it's going to help you solve that problem. One example of this is that you can calculate the rotation of a wheel, for example, based on knowing how far that wheel has travelled and the circumference of the wheel. But what exactly is the circumference of a circle? Well, it's the distance you would have to travel if you started at a point on the circle and you worked your way all the way around the edge of the circle back to where you started. So if you started at a point and we worked our way all the way around the edge of the circle and back to where we started, travelling on the line of the circle itself, the edge of the circle, that distance would be the circumference. Now hopefully we can see that it's quite logical that as the radius of the circle gets bigger, that distance we have to travel, the circumference of the circle, is also going to get bigger. We can see with this circle of enlarged radius, we would have to travel further to work our way around that circle than we would this smaller inner circle. Now in fact, Euclid proved that this relationship is proportional. That is to say, if we scaled the radius of a circle by 2, the circumference of that circle would also be scaled by 2. Now the maths behind this proof is a little bit complex, so I'm not going to get into it here, but just trust that there is this direct proportional relationship between the radius and the circumference of a circle. And that means if we take the circumference and we divide it by the radius, we're going to get a constant value. And this value is the same for every single circle in existence. So that means if I take the circumference, I'm going to use a capital C to represent circumference, and I divide it by radius, we're going to get a constant value. That value is the same for every single circle in existence. Now I will quickly note, I've used a lowercase r here, whereas in previous videos I've used a capital R. It just seems to be one of those weird convention type things where maths textbooks, when we're dealing with the equation of a circle, seem to use an uppercase R for radius, whereas maths textbooks where you're dealing with the circumference of the circle and an area of a circle, they seem to use a lowercase r. So just keeping with convention, I've chosen to use a lowercase r here. When you're talking about a circle, lowercase r and uppercase r, they both mean radius, they both mean the exact same value. So when you're dealing with circles, don't worry if you see an uppercase r or a lowercase r in an equation in a textbook, they mean the same thing. So we could define this constant value using our circumference divided by radius. However, by convention, instead of using the circumference over the radius, the convention is to define this constant value using circumference over diameter. And what is diameter? Well, our radius, we know, is the distance from the center point to the edge of our circle. The diameter is the distance across the entire width of the circle, making sure that we pass through the center point. So hopefully we can see that diameter is equal to 2 times radius. So the convention, instead of having C over R, the convention is to have C over D, which we know is equal to C over 2R. And this constant value, as defined by C over 2R, is perhaps the best known constant value in the entire world of mathematics. It's pi, which is written like so. Now, pi is an irrational number. That is to say, it goes on forever. Computers have been calculating the value of pi to a huge number of decimal places, but their work will never be done because pi's value just keeps on going past the decimal point. Now, for most practical applications, we can actually use a rounded version of pi, and that's going to be fine for our needs. And you'll find that almost all programming languages, certainly C and Python, etc., they will provide pi as a constant value within the maths library that you can get access to so that you can reference the value of pi without having to actually program that in yourself. Now the value of pi is approximately equal to 3.14159, and that number keeps on going. But to be honest, I only ever remember that the value of pi is approximately equal to 3.14. That's all I've ever need to remember, because most of the time if you're working out equations, you either leave it written in terms of pi, or you're using a computer which can have the value of pi stored in, so you don't ever really need to remember the value of pi yourself. So we know that c over 2r is equal to pi. That is the very definition of pi. It's where that value comes from. So we can then rearrange this equation to find our circumference in terms of pi and our radius. So if we rearrange this equation right here, we're going to see if we were to multiply both sides by 2r, we're going to see that our circumference is equal to pi times 2r. This is more commonly written as c is equal to 2 pi r. So this is the equation for the circumference of our circle given the radius of our circle. And we know, of course, that pi is a constant value, 2 is a constant value, so it's just defining the relationship between the circumference and the radius of our circle. Now, we can also, of course, write this as c is equal to pi d, depending on if you're using the radius or the diameter. I tend to always remember c is equal to 2 pi r. I prefer to work with the radius of the circle, but you may encounter people saying c is equal to pi d, or you may find it easier to work with the diameter in certain cases, in which case they are equivalent of, so we've already seen that diameter is equal to 2 times our radius. So it's a very simple equation. It actually has quite an interesting history. We've barely scratched the surface of the history in this video. So if you're actually interested in that kind of thing, if you search on Google, for example, for the history of pi, there's a wealth of information out there on the internet. So if you are interested in that, I recommend you look into it, because ancient civilizations have actually been using approximate values for pi for thousands of years. It's really quite fascinating how they have been using approximate values of pi for quite complicated calculations all those years ago. So that's a little bit of history over pi, and it is our equation for finding the circumference of a circle. So now that we have that equation, let's use it to answer a few questions. So I'm going to set you some questions. Since it's very easy to use this equation, there's no need to work through any examples. I'm just going to set some questions, and hopefully you'll be able to answer those questions. So question 1. I'd like you to calculate the circumference of a circle where the radius is equal to 3. So what is the circumference? And you can leave that in terms of pi. So you can leave it as some number multiplied by pi rather than actually putting pi into a calculator and getting some long number with loads of decimal places. Just leave it as a multiple of pi. So go ahead and pause the video now. Give this an attempt. If you have a solution or get stuck, then unpause the video, because I'm going to work through it on the whiteboard. Okay, welcome back. So this is really simple because our equation's really basic. We know our circumference is equal to 2 pi r, which is equal to 2 pi 3, since our radius is 3. Well, 2 times 3 is 6, so if we're leaving this in terms of pi, our circumference is equal to 6 pi. So really, really basic. But what about if we had, for example, I don't know, let's say question 2, what about if we said the circumference of our circle is equal to, I don't know, 12 pi, what is the radius of our circle? So similar situation, but it's obviously going to require to rearrange that equation a little bit, but go ahead and attempt this, and when we come back I will give the solution. Okay, welcome back. So we know that c is equal to 2 pi r. That means that radius is going to be equal to c divided by 2 pi. Well, in our case, our circumference is 12 pi, so radius is equal to 12 over 2 pi. My apologies, 12 pi over 2 pi. The pi's cancel. 12 over 2 we know is 6, so the radius of our circle is 6. So just one last question that I'd like to ask. It's actually going to combine some of the knowledge from previous videos along with what we've just learnt. So let me set one final question for this video. Okay, so what is the circumference of a circle that is centered at the origin if we know that there's a point on the circle that has the coordinates 4, 3? Now again, you can leave your answer as a multiple of pi, so your circumference can be a multiple of pi. So again, this is a point on a circle that is centered at the origin. What is the circumference of that circle? So go ahead and pause the video and attempt that. If you get stuck, or once you have a solution, unpause the video and I'll work through it here on the whiteboard. Okay, welcome back. So it's not too challenging. We already know that if we know a point on a circle centered at the origin, we have that circle equation that relates coordinates of points on the circle to the radius. That means we can work out the radius of the circle. And once we have the radius of the circle, we can then use that in our circumference equation to find the circumference. So we know that x squared plus y squared is equal to r squared from earlier videos. So that means that r is going to be equal to the square root of x squared plus y squared. So we can then put our coordinates into this equation. So our radius is equal to the square root of, well, x squared is going to be 4 squared plus y squared is going to be 3 squared. Scroll down a bit. That means our radius is equal to the square root of 16 plus 9. Radius is equal to the square root of 25. And we know because radius is a distance, it's going to be positive, so radius is equal to 5. Now that we have that, we can plug it into our circumference equation. So c is equal to 2 pi r. We've already said capital R, lowercase r are interchangeable, so it's equal to 2 pi capital R. That means that c is equal to 2 times pi times 5, which if we're leaving our answer in terms of pi, c is equal to 10 pi. And that is the circumference of our circle where we had the point 4, 3 on a circle centered at the origin. So as I mentioned earlier, this equation, the equation c is equal to 2 pi r, is incredibly simple and there really is nothing to it. But it's just one of those equations that's useful to know. It's just another tool that you can use when it's appropriate to use it to help solve problems. So I hope you enjoyed this video and I hope you find knowledge of this equation is useful to you in the future. Thanks a lot, everyone.